Let's fix that. That screen. Okay, share. All right, so here is the correct screen to share. And hopefully my Pendleton students will get into the right link so they can talk back to me. Let's see what I want next. So Anna, did you get the email I sent that has the link to the materials?
Mm-hmm.
Okay, so that should bring you eventually to this page here. Did you get to that page yet? For Stats Lab optional?
Oh, yeah. Mm-hmm.
Okay, so you click that.
Yeah, I'm on it.
And then a couple things that you'll find here. You'll find the link to the lab 2. So this is the description of what we're going to do. And then in here, under human body temperature, is a link to the data that we're going to work on. And you can do a control click to launch that in a new window, I think. Or is it? Let's see. Oh, point and then click the link underneath. There you go. So that takes you to the actual data. All right, Pendleton people, anyone get the link about the live broadcast? Maybe somebody on that computer with the video camera and microphone. If you need help, you could grab one of the other teachers around. Otherwise, just listen and follow along. So let's see, Patricia and, let's see, who else am I missing? I am missing Patricia, William, and Mariana. I was hoping that you would be here in Hermiston with me. All right, so let's go do something here. So we'll look at the particulars of this description in a little while. What we're going to do is grab that data. Now, I recommend using Google Sheets. It's easier to use than Excel, but if you want to use Excel, that's fine too. And if you have questions on it, I'll be glad to answer them. When you click on the link here, so let me copy this link and put it in a window so it'll appear like you see it. You'll get it as view only. And that's not good because we want to edit the data. So what you want to do next is go to the File menu. Come on, File menu. Oh, you have to be signed into Google for this to work. So you have a couple options here. If you use Excel, go to File, choose Download. My recommendation is that you sign into Google.
Or make a copy.
And make a copy, correct. Yeah. So I'm going to sign into Google with a different account here. Okay, so let's see. They can hear. They're watching. All right. So we're going to move along. So if you're signed into Google, then you should have the make a copy option. Give it a better name than that, like put your name, Lab2, something like that. So I'm going to go by Bo as my pseudonym. So Bo's Lab2 data. You can always change the name at the top of the document to whatever you want. Other thing, if your Google Drive is anything like mine, you've got a ton of shit in it. And so you should put it in a place that's special. So for example, I could go to the File menu, and Organize is kind of like Save As. It allows me to put it in a different spot. So I could move this from my main Drive folder into some other Drive folder. And so I have a folder for math stuff here. And in my folder for math stuff, I got a place for Math 243. Maybe I want to make a new folder for Stats Lab. So I can add a new folder to my drive, and then I can put this file in it. So that's just kind of extra stuff. So what I want to do is analyze this data. So we're going to analyze the data in a few ways. One nice thing about Google Sheets is it makes a histogram really fast and easy. So let's just check out this data. First, let's try highlighting all the data. So I click in the middle of cell A1, and I drag down. And hang on a second here. Pause, answer. Not gonna work. Hello. Hi. Ooh. Shit. Feedback. Can you hear me? That was bad. All right, let's go double check. I got a video call from Laura, and that did not go well. So let's see, where's my other data? Let's move this for now. We'll get the technical details out later. So let me see, I am math coach. So Camden sent me a message. All right, so did you try the link? Oh, and there's Laura's. Okay, Laura, you're sending me a video call. That's not going to work very well. Stop. Oops, hello. We're going to try to stop doing the video call. It's not working well. Okay, did you try the link that I emailed a few minutes ago? So let's go back. All right, so did you get that data open there, Anna?
Mm-hmm.
All right, so nobody else is in the live broadcast, they're just watching it. Let's try one thing. It shuts down because of an error. Oh, bummer. Okay, let's try one more thing. Oops, wrong button. Was it? Try this one. Okay, oops, 2. The number right? Yes. Okay. So we'll proceed with some data analysis in just a minute. Once we get these technical things out of the way. Let's see when that one says it shuts down because of an error for all of us through Google. Weird. Okay. Oh, Laura, hi.
Hi, we're all still trying to figure out how to log on.
Okay. So there's 2 ways to do that. So okay. So there's 3 feedback.
I did. Did we get it?
There's 2 of you on there.
Go after you log on. I can see you. I can see you.
Oh, that's funny. All right, to mute your mic, please. Amy.
How did you get it to work?
Hello, can you hear me now? Oh, good. Close up of Laura. I see Shyla. Excellent. Who else do we have over there? Let's see, where's the chat? Over here. Hello, Pendleton. Who is there? Who is there? You guys see that chat box? Should we try this a different way? We'll learn the technology soon, don't worry. Let's see, do we have Mimeo here? Somehow I lost audio from you guys. Is that Mariana over there? No, that is Lauren. Hi, Lauren.
Hi.
Okay, that doesn't work. Let's try this. Why can't I hear you guys now?
At this point, Professor,
Somehow my speaker shut off.
Professor,
You see a little chat box on the right? So you can write little, oh, Camden's in there. You can write little chat messages to me. Hi, are you Mariana?
Shut up.
Patricia! Oh, I had 50-50 chance there. Welcome. I can't hear you guys still. Chat
Professor,
box on the right. Can you see the chat box you can type in? Somebody call my cell phone.
oh my gosh.
No, fine, we'll get the starboard up and running. Starboard.
You guys having technology problems?
Oh, there's Pete to the rescue. Hooray!
Then turn off your mics.
Well,
Can you guys find the chat box? Somehow my mic stopped, well, no, my speaker stopped working on this side. Not sure why. And where is the starboard? So you've been getting my emails?
Yeah.
Okay.
I found it right.
Okay. Oh, got my starboard up slowly.
So you should only turn your mic on.
Okay.
All of the times your mic should be off. Also, it's
Where's the magic pen? Oh, no magic pen.
so.
Hmm.
Any other issues?
You missed the
Alright, is there a text button here?
Yeah, like this is solved.
Oh.
call. Okay.
4, 2, 1,
Yeah, I'm gonna call him.
2, 9.
At this point, I just follow him with him. I'm just trying to figure it
Four
out.
assistants.
It's crazy.
I think we got a cell phone coming out there. 298. Yeah, that's my number. Here we go. Hello, Laura. Hi.
Hi.
Okay, so let's see. We have some issues going on. Let's troubleshoot them. So, can you hear me on the computer?
Yes.
Okay, I can't hear you. Something went wrong with our audio feed on this side. It could be the webcam on your computer there is got a problem. So it could be that's defective. It was working at first.
Now you can't hear none of us?
I can't hear anything now. So somehow either my speaker cut out or your mic cut out. So I'm not sure.
Problem that we're having right now. We
Yeah.
can hear you, but we have 3 different computers out to watch you, and every time you talk, like it will start with me, and it will repeat what you said, and then it will go to the next person, and then it will go to the next person. Nothing
Oh,
is,
so there's a delay going on.
so everything's echoing, and
Cool. Okay, so what you could do is you could turn the volume off on each computer but one.
okay.
So just hit the volume button in the bottom right corner of your screen and mute it.
And then just all kind of huddle around one computer, or
Otherwise, I'll find a better option for next time.
It's trying.
at this point, maybe I'm just thinking that we should just, you can record the video and then we can watch it on our own time and try to follow along and try.
I already, just in case we had technical difficulties, I recorded another video. And
You
so
did
I'm
record
gonna
another video?
So I'm going to send that to you all right now. Actually,
Okay.
you can get to it. So actually, I'll just send you the link to it.
Okay.
So let's see. Where did I put it? Numbers. Yeah, so give me just a minute. I'll send that to you, and then we'll fix these problems next time.
Okay. All right.
So-
That sounds good.
So check your email, and the first couple of minutes is me babbling about stuff, and then I jump into analyzing the data for this project.
Okay.
All right,
And
so I'll
then
send that
there's
to
an
you.
assignment with it?
So in the main course website,
Main course website.
under Stats Lab,
Okay.
is the description of Lab 2.
Okay.
And that takes you to this page that's going to pop up on my screen here. And then there's a link to the data that you need to analyze.
But it's okay.
And so I have a video of me analyzing that data so that you can answer the questions below.
I don't see anything in my stats lab. So check out the lab. Okay, I found it. All right.
Found it. Okay. All right. So I'll send that video in just a minute.
Yeah, I was the one that
Okay.
I should have any other questions.
Okay. Thank you. Oh, really?
Yeah.
Patricia, were you able to find this Stats Lab from your email?
He said that he.
So I emailed it to you just a little while
I
ago,
got it.
so check the MCC email for that. Okay, so let's send them the video.
He said that he had already recorded a video.
Where did I put it? Here, no. Here, no. Here, no. That's this one. That go away. Part 2. Some measures. Oh, I know where it is. Different. There's my other accounts. This one. This one. All right, here somewhere. Let's go here. Oh, I know where it is. YouTube. My computer wants to work. Come on, YouTube. Let's go. Okay, statistics. So I have a statistics channel, and the last video is the one we want. So I'll share both the channel and this link with everybody. Send a new message. Let's go to send now. How about, which one do I want? This one? That one should be to everybody. Okay, so reply to all. Pre-recorded to. All right, it's out to you. So that video goes over everything we're going to cover. Did you find the video yet? Did you find the Stats Lab yet? From your email?
Yeah, I found it.
Okay. And that should give you a link to my Open Math. And that link to my Open Math, where did I put that? Let's see, back here somewhere. Should take you to a page that looks like, whoa, this computer is having issues. Oops, I erased too much. Yeah, so scroll all the way down to the bottom and get down slabs. Okay, just put the last that has a data. You have a Google account? Yeah. Okay, so we'll want to sign in your Google account. So, you already signed in. Okay, so go to file and make a copy for yourself. And give it a better name. So, Yeah, so just call it like so, and then we can start editing together. All right, so let's do some data analysis. So let's see, Anna, you've got the data, right?
Mm-hmm.
And Mariana, did you have your copy of the data now? Sorry, wrong one. Patricia, I'm sorry. I made that mistake when you got in and I got all confused. All right, so I'm going to start analyzing the data with you. So first thing we need to know is just scan the data, take a look at it. So I'm going to start with A1. I'm just going to highlight and scroll down. And there's 520 numbers in this list. I'll tell you ahead of time. So when you get near 500, you want to slow that scrolling down a little bit. There's also an extra number. So we'll have to check out that extra number in just a minute. But the first thing I want to do is, since I have all the data highlighted, Google Sheets will make a histogram for me super easy. So with the data highlighted, I go to the Insert menu, and then I choose Chart. And Google will say, hey, do you want a histogram? And I say, yeah, I do. So it picked a bin width here that appears to be about 3/10. Looks like it's about 3/10 wide. And so this is what that histogram looks like. If you want to alter the bin width in the histogram, you go to Customization. Customization, there we go. Here you can give it a better title. So these are body temperatures of people. So I'm going to put a better title here. Body temp of people. And there's only one set of data here, so I don't need a colored legend. So where it says legend underneath that, I can switch from right to none. And then I want to scroll down a little further. Other things I can mess around with. Bucket size is your class width, right? You guys read about class width and work with that with Mr. Herrenberg. So I could try a different class width, see what it looks like. So it gave me a class width of about 0.3. What would a class width of 0.5 look like? So I could go to bucket size and type 0.5, hit enter, and it redraws the histogram for me. I could try 0.4, see what that looks like. So I can play around with different histograms. Let's say I like the 0.4 one. It doesn't have too many categories, and it doesn't have too few. Scrolling down a little further, if I sent this chart to my mother, she'd be like, I'm not quite sure what these numbers mean, Gary. So I'd want to put some labels in here. So under axis horizontal, I could put a title that says degrees Fahrenheit. So my audience knows what the heck they're looking at. And I think I spelled Fahrenheit correctly. Other thing, some people might look at this and know exactly what the vertical column means. Patricia, could you tell me what the vertical column means in this graph? No, that's the horizontal axis. What's the vertical one mean? Yeah, number of people that have that temperature range. But not, my mom is not going to get that. So maybe I want to switch from axis horizontal to left vertical and put in there that that's the count or the frequency, right? So I'm going to call it frequency, although my mom might prefer count. So I always ask myself, would one of my colleagues get this? Would my students get it? Would my mom get it? And so I hit enter, and it puts that in there too. So that's a pretty good graph. Other thing, though, that's unclear about this graph, the boundary numbers, 96.4, 96.8, 97.2, and so on, are those numbers in the bin to the left or the bin to the right? And I am 90% sure that the number 97.2 is the first acceptable number in the bin to the right. Usually when we use the frequency command, it says the 97.2 is the last acceptable number in the bin to the left. And so we should always double check that. And I don't know why I can't remember that particular fact here, but we could test that out later. All right, so then I can just insert it. Now the downside here is that Google doesn't give me a frequency table. So if I wanted a relative frequency histogram, I'd have to make that by hand with the frequency command. So if I scroll all the way back up to the top, I'll see it dropped in a pretty chart. But I don't have a frequency table to go with it, which means if I wanted a a relative frequency table or a relative frequency histogram, I'd have to use the frequency command to create that. But the nice thing is Google, out of raw data, makes a histogram really fast, which is nice. All right, so let's scroll down through the data again, go all the way to the bottom, row 520 something. I had an extra number at the bottom. And if I double click on that number, Google tells me, oh, you calculated the average of the numbers above. I didn't label it though, so it's kind of confusing. So off to the side here, I should put a little note, average. Anytime I do a calculation, I want to make a note. What is that number? So now we're going to do the calculations we need to complete the lab. So we're playing with descriptive statistics here. We're going to go over one topic you haven't covered yet in Hermiston called standard deviation. So I'll try to explain that as we go. So the things I need to know here, I want to count how many numbers are in this list. And I want to see that count. I want to know the min. I want to know the first quartile, Q1. I want to know the median. Now median we usually just call M for median. You could write the whole word median if you want to be more descriptive. I want Q3, I want the max. I'm going to put a little space here, and other numbers I want to calculate are the mean. Anybody remember what symbol we use for the mean of a sample as opposed to the mean of a population? It's either mu or X bar.
X bar.
X bar, yeah. So you can't easily put an X bar in here, so the best I can do is either type mean or type X bar. And I'm going to type X bar because I'm trying to be clear to you and our other friends that this is the mean of a sample, not the mean of a population. And then standard deviation, often I abbreviate that STD, standard deviation. If it's a sample, you use the letter S for a sample. If it's a population, you use the small Greek sigma. And so sigma looks like, let's scroll down here. This is the small Greek sigma right there. And that isn't always accessible easily in a spreadsheet. You probably remember the capital Greek sigma. Anybody remember what that one means in math? Think about a spreadsheet. There's a button with that on it in a spreadsheet. What does that button do? It does give you functions, but it's got actually a more specific purpose than that. It adds stuff up for you. It's the auto sum button. So this capital sigma means sum, add stuff up. And this lowercase sigma means the population's standard deviation. So you'll see more about that later. If it's a sample standard deviation, we use S. So I'm just going to call this S. I could off to the side put another note. This is the mean, X bar, and this is the standard deviation. I can make that column a little wider so I can see that. All right, so I'll get more into what standard deviation means in just a minute. So let's do these calculations. There's two ways to get a formula going. You can go in, you can click on a cell, go to insert, go to function, and find the formula you want. Or you can guess and start typing. So I'm going to guess and start typing. So in the cell next to count, I'm going to type equals and start typing the word count and see if anything pops up. And so Google gives me all these options, and there's count. If you're in Google, you can click count, and it will type it out for you. If you're in Excel, you have to double click or hit tab. Then it wants you to select the data. Okay, so then I go over here and I start selecting my data, and we want to select all 520 elements, but not the average at the bottom. And so it selected for me cells A1 through A520, close the parentheses, hit enter. Now, it didn't take a lot of time to highlight all those cells, but if I do this a bunch of times, it's going to get annoying. So here's a shortcut if you're going to reuse the same group of cells. If you double click on that formula, highlight the phrase A1 colon A520 and Control C on the keyboard to copy it. Then anytime we need our data, we just paste it in where we need it. for that reference. And so this is a relative cell reference for a group of cells. So similar for the min, I'm going to type equals. I'm going to start typing mi. I finish it with an n. It says here's a bunch of min things. First one says minimum value of a numeric data set. That's what I want. I can hit tab to complete that, and then control V to paste my data selection in there. Close the parenthesis, hit enter. Next, quartile 1 equals, start typing the word quartile. That's the only option. Hit tab and Google will type it for you. Paste your data in. Which quartile am I trying to calculate here?
1.
The first one, so I do comma 1. Find the first quartile, the place that marks the lower 25%. Hit enter. And just let's keep repeating this. Do median, Q3, and the max. Median just takes the data. And quartile again. Paste the data selection in, comma, quartile 3 this time, close parentheses. Max. Oops, remember to type equals first. Paste, close parentheses. Now, if in Google, if you forget to do something like close a parentheses, it'll guess and close it for you. In Excel will freak out and give you an error message. All right, X bar, that is the average. And I need the data. S, the standard deviation, start typing ST, and it gives me a bunch of options. So let me explain these options quick. So STDEV is the regular standard deviation. That finds the standard deviation of a sample. It turns out that you calculate the standard deviation of a sample different than you calculate the standard deviation of a population. So every time you use standard deviation, you have to ask yourself, is this a sample or a population? STDEV is identical to STDEVA. They have slightly different descriptions, but they do the same thing. So I would get the same answer whether I choose the STDEVA or STDEV. STDEVP means I'm finding the standard deviation of a population, and that will give me a slightly different answer. This isn't a population, so I either have to use A or the basic one. I'm going to go for A. That's the more appropriate one to use here. So I hit tab to complete it or click on it, paste my data in, and then hit enter. Now, general rule for data, it depends on who you talk to. Some people say when you do a calculation based on data, you should have one more decimal place of accuracy than you have in your calculation than you have in the data. So that means here, if I have the 10th, my calculation should be at least to the nearest hundredth. The book will often say take it 2 decimal places extra, or the homework will say that. So always pay attention to the fine print. Here, I think 2 decimal places is sufficient. So I'm going to highlight my mean and my standard deviation, and I'm going to decrease the decimal to 2 decimal places, so to the nearest hundredth. Another phrase I could use for standard deviation, I could say it's a measure of the average spread. So I'm just next to it, I'm going to type average spread. Okay, so what the heck is deviation? So I brought a thermometer with me, and so I'm going to measure my temperature. I measure at 98.2. Is my temperature average, according to this data?
90, what did you say?
I said 98.2 is what this is telling me. So I'm a little below average, right?
Yeah.
Okay. If I look at other people on the screen here, 96.5. So I measured a person, they were quite a bit below average. Some people are above average. Here's a 98.7. Somebody was 99.4. Right? So their temperature deviates from the average. Agreed? So deviation just means how far are you from average. So I'm just going to do a couple calculations off to the side here. Let's go over here and type deviation. So to calculate someone's deviation, you just find their measurement and subtract the mean. So for example, right now, I just measured 98.2. If I subtract the mean from that over here, then my deviation is about negative 1.8. If I pick on somebody else over here, like maybe the 96.5, let me colorize that. Let's make it yellow. And let's make this cell yellow. So I go over here and I type equals, and then I click on their temperature, and then I subtract the mean from that. I can see their deviation was negative 1.8. Let's do one more just for fun. Let's do the 99.4. Let's make that a color. How about pinkish? And go over here and apply the same pink to kind of keep track of it. So then I hit equals, I click on their temperature, and I subtract the mean. So if you always do it in that order, some individual's measurement minus the mean, that's deviation. If the deviation is negative, they're below average. If the deviation is positive, they're above average. Now, somebody could have exactly the average temperature, in which case their deviation is 0. Okay? Now notice, none of these are equal to the average deviation. Standard deviation could also be called average deviation. But there could be somebody in this list has exactly the average deviation. So what we do is we use the average deviation as a measuring stick. So how many standard deviations am I from the middle? How many standard deviations is this yellow person from the middle? To figure out how many of this live inside of that, I just do a division. So let's do that off to the side. So I'm going to do another formula. I'm going to do equals, scroll over a touch, and I'm going to click on this deviation, and I'm going to divide by 0.71. So this tells me this person is about a quarter of a standard deviation below average. Okay. Now I'm just going to repeat that formula, so I'm just going to fill this down twice. And so off to the side, I'm just going to state what these second group of numbers mean. So this one right here, and let's round it to like the nearest hundredth. So this person here is about 1/4 of a standard deviation below average. My spreadsheet does not want to scroll over. There we go. So this person right here, I would interpret the negative 2.65. You know, 0.65 is kind of close to a half. So I'm just going to round it down a little bit. So I could say this person is about 2.5 standard deviations below average. And then the 1.43, I'm just going to round that up to 1.5 to make it easier. I could type the exact thing, but I could say this person is about 1.4, say, standard deviations. Now, would this one be above or below? Yeah, it's above because it's positive. Standard deviations above average. So often standard deviation is just used as a measuring stick. So it's a common measure for a particular data set. So rather than say, I'm exactly, so what does this number mean in the deviation? That's degrees Fahrenheit. So I'm going to put an F under there. So this one says the pink person is about 1 degree Fahrenheit above average. The yellow person is almost 2 degrees Fahrenheit below average. I could instead say, you know, they're about 2.5 standard deviations below average, or about 1.5 standard deviations above average. And as we move through the course, we'll see more why we need to talk about things in terms of standard deviation. And so it's just another measurement we have to get used to and talk about. A common thing this comes out with, distribution means the shape of a histogram, for example. And there's a certain shape called a normal distribution. So I'm just going to search for normal distribution because I want to show you some pictures of it. A normal distribution has a bell-shaped curve. And I'm going to steal, let's see, this graph over here. I like this one. Let's open that in a new tab. Oh, that's not what I wanted. I want to see just the image. Open image new tab. There we go. And let's blow that sucker up. So there are different shapes of bell curves. Some are wider, some are narrower. But one thing that's always true about bell curves, if you make your horizontal axis standard deviations, then if you look one standard deviation to the left and one standard deviation to the right, if your data is normally distributed, you should expect to find about 68% of the measurements live between one standard deviation to the left and one to the right. So what we're going to do is we're going to calculate that for our data and see what happens. So we need to go back to our spreadsheet. And so we're going to make some more entries down here. So let's say underneath S, let's go down about 5 rows. That should be good. And right here, what we're going to type is X bar minus, let's do plus S. X bar plus S. And we're going to calculate so what does that mean? That's one standard deviation above the mean. Right? X bar is the mean, S is the standard deviation. So we're going to calculate what number is one standard deviation higher than the mean. So over here, we're just going to go equals, click on the X bar value, plus, click on S's value. Hit enter. So this tells me if somebody has a temperature of 99.1, they are one standard deviation above average. Okay? Let's go over here and do one standard deviation below average. So X bar minus S. So then we go next to it, we'll go equals, click on the mean minus the standard deviation. So this tells me if somebody has a temperature of 97.67, so 97.6 or 97.7, they are about one standard deviation below average. So the next thing I want to have the computer do is I want the computer to count for me how many people have a temperature of 99.1 or lower. All right, so I'm just going to make a note about what calculation I'm doing. I want to count people that have a temp, T, that is less than or equal to 99.1. So I'm just making a label. Next, I'll tell the computer to do that for me. So remember earlier at the top, we said, can you count all the data, Excel? And Excel said, yeah, there's 520. It turns out there's a way to tell it to count if the data meets a certain condition. So let's try that. So off to the side of that right there, I'm going to type equals. And I'm going to type count again because I do want to do a count. And notice it gives me a bunch of different ways to count things. I want count if. What count if does is it says, okay, show me some data and then tell me what condition the data has to meet, and I'll count anything that meets that condition. All right, so I'm going to hit tab to complete count if, and then it wants to know where's my data. I think I've copied and pasted since earlier, so I'm just going to have to type A1 colon A520. And what that'll do is it'll grab all the data starting in cell A1 and going all the way up to 520. Comma, then it says, okay, what's your condition? And notice they're showing me how to type the condition. It says put a quote first. So first I put in the double quote. So I go shift, hit the quote, and then it says the condition. Okay, so my condition is less than or equal to. To get less than or equal to, you just type less than, then equals. And then type the number 99.1. Then we have to close the quotes and then close the parentheses. And what this command should do is it should look in the cells A1 through A520, find any numbers that are smaller than or equal to 99.1, and keep track of them. So I'm going to hit enter, and it says 442 of the numbers are less than or equal to 99.1. So let's see if we can reproduce that same command for the number 97.67. So let's see, it's equals count if, okay, and then our data is in A1 colon A520, and I could have highlighted it too, get that to say that. And notice the A doesn't have to be, it's not case sensitive here. Sometimes things are case sensitive, this isn't. Comma, and then our condition. The condition has to start with quotes. Our condition is we want to find numbers that are less than or equal to 97.67. Close the quote and close parentheses. Okay. Oops, I put the thing in the wrong spots. Just going to drag that over, cut and paste it, Control X, Control V. Here I meant to put a description of what it was. I want to count temperatures that are less than or equal to 97.67. So the computer says 69 of them are. So I want to draw a picture of what we just calculated. So let's go back here. So I'm going to attempt to draw a normal type curve. So let's make believe our data has this bell-shaped kind of curve. That's not bad for drawing with a mouse. Okay, make believe that's symmetric. I did my best. If the data is normally distributed, then the mean should be exactly in the middle, splitting the bell into two symmetric halves. So according to our data, our mean is about I'm going to call it 98.4. So 98.4 should be right in the middle. Now, if I look out here, I want to know what number is one standard deviation. So I'm going to call it 1s to the right. I also wanted to know what number was one standard deviation, so minus 1s to the left. And we just calculated those numbers. So let's see, what did we calculate? The one to the right was 99.1, is that right? So 99.1 degree Fahrenheit is right here. And to the left was 98 point, what was it? 97.67 is right there. And then I'm going to switch colors again. Let's try red. The calculations we just did, we found, what was the first count we did? 400 and something? 442. So we found from here all the way down, there were 442 people in that region. 442 people had a temperature of 98.1 or lower. Then we calculated on this one, how many people had a temperature of 97.67 or lower? 69, thank you. So that one was 69. So if 442 of them had a temperature from here and lower and 69 had a temperature here and lower, would you agree that if I were to subtract those two numbers, that would tell me how many people fit in between here? 442 minus the 69 should give me what's in the middle here. So what is that number? So I'm going to go back to my spreadsheet and make that calculation. So off to the side here, let's put it right here, say, I want to know equals, what is 442? So click on the 442 minus, click on the 69. Computer says there's 373 individuals live in between those two temperatures. So I'm just going to put some words next to that for what that number means. So 373 people are within one standard deviation of the mean. Sometimes when we're talking stats, it's nice to tell somebody an exact number. Sometimes we tell them a percentage. Okay? How many people are in my data set here? Remember? 520, yeah. So I want to know 373, what percentage of that is of 520? So that's just division. So underneath there, I'm going to put equals. I'm going to click on the 373 and divide by 520. I'm going to hit enter. So looking at that, it looks like 72-ish%. So I'm just going to tell Google to display that as a percentage by clicking on that cell, then click on the percent. So it gives me 2 decimal places. I could drop it down to 1 decimal place. My mom wants 1 decimal place better. So about 71.7% of the people are within 1% of the population. If the data was normally distributed, the general rule is we should find about 68%. Is 72 very far from 68? It's not too far. It's a little far, but not bad. Okay. So we're going to try and check these other percentages. Okay? That's what we're going to do next. So let's go back to the data. And so this same sentence would work. 71% of people are within 1 standard deviation. So I could just copy and paste that same sentence there. Control C, Control V. I could state it in terms of raw people or a percentage. So we're going to reproduce this for 2 standard deviations on each side. So we're going to see if our data is close to the 95% mark. Some data is, some data isn't. You never know. So let's go underneath here a little bit and type the label x bar plus 2s. And underneath that, we'll calculate x bar minus 2s. So we're going to look 2 standard deviations to the right. We're going to look 2 standard deviations to the left. So to do the calculation, type equals. Make sure, so I'm doing the plus 2 to the right. Click on your average. So starting there, we want to add 2 times. And you got to type the 2 and the times, and then click on the standard deviation. And the computer will calculate, and the computer says about 99.81 is 2 standard deviations above our average. Repeat that for 2 standard deviations below. X bar minus 2 times S. Enter. So I have a couple options here, and I want to just write it down in math in a picture. So the first thing we did for the 99.1 for this 420 is we said we want to find all, usually we call our data x values, all x values that are less than or equal to 99.1. And that's where the 420 came from. For the 69, we said we wanted to find all x values that were less than or equal to 97.67. Man, I gotta get a better pen. Writing with the mouse is no fun. Okay. The numbers in the middle could be written as a compound inequality. They are all x values on one side that are less than or equal to 99.1. And they're greater than 97.67. Right, remember doing compound inequalities in the previous math class? And again, the way this is read, you always read from the variable. So this says, in other words, find me any x values that are less than or equal to 99.1. And they also have to be greater than or equal to 97.67. So there's 2 ways to state a compound inequality, with an and connecting the 2 or with x in the middle. That says give me everything in the middle here. Okay. So on paper, we got used in previous math classes to writing it this way. Wouldn't it be nice to give Excel that and tell it that, and then it would count everything in between? In Excel, we'd have to give Excel or Sheets this way. So this is like the spreadsheet way to type it. So spreadsheet way. And this is like the human way we like to write it. This one looks good to my eyes. This one looks good to the computer's eyes. So we're going to just do the next calculation in a couple of different ways and compare the results. So there's 2 big goals in this class. One goal is to help you guys learn statistics. The other goal is to help you use a spreadsheet better. So I'm going to use a spreadsheet wherever possible. All right, so let's see if we can reproduce the count commands we had above. So I'm just going to type a little note. I am trying to count the temperatures that are less than or equal to, in this case, 99.81. And then I'm going to try and count the temperatures that are less than or equal to 96.96. 96.96. So I go to the cell I want to start with. I type equals and start typing counts. Click on the count if. Range of data was from A1 to A520. Colon connects those. Comma, quotes, got to remember the quotes, and Google will prompt you, type it like this, please. So I want to try and pay attention to that. Let's see, what are we doing here? We are going to be less than or equal to 99.81, close the quote, close the parentheses, and hit enter. And so 514 of them. And again, so check the picture here. I'm checking how many people are less than 2 standard deviations, so I should find more of the population is here or below. Next, we're going to check the -2, and so we should find a pretty small number live in this area over here. That's what the distribution is showing me. There's not many people over here. A lot of people in the middle. Okay, so back to the spreadsheet. So equals count if A1 through A25. Oop, 25, 520, that was strange. Comma, quotes. Let's see here, we want to be less than or equal to 96.96. Close the quotes, close the parentheses, and hit enter. Yeah, there's only 18 are down in that bottom tail. So if I want to know how many live in between 2 standard deviations, I have to subtract these 2 numbers. So that's my next step. So equals, click on the 514, minus, click on the 18. Google says 496 of your people. That's like most of them, right? 520. Underneath, let's find out what % of that is 520. So equals, what is 496 out of 520? Make it a pretty percentage. Google says about 95.4. This picture of a normal distribution, those percentages are called the empirical rule. And the empirical rule says that if your data is normally distributed, there's never a guarantee data is normally distributed, by the way. But if it is, you should expect to find about 95% within 2 standard deviations of the middle. Are we pretty close to 95%? Yeah, oh, that's kind of cool for whatever the empirical rule is worth. And it's worth something in statistics. We'll get more into that as the course goes on. So we counted how much of our data is in between these 2 numbers here. And we had the computer help us do that. Now, if there were only like 20 numbers in the list, we could totally easily do this by hand, way easier than these formulas. But the bottom line, in reality, data sets are usually quite big. And 520 is not that big. But how many, would you like to look and count these by hand? No, I don't think so. I wouldn't want to do that either. So it's nice that the computer has these formulas that we can do. And generally, I'm not sure of all the formulas Excel and Sheet has. I know maybe 10% of them. I have an idea about something I want to do, and what I usually do is I just make a Google search. And I would type something like Excel, count numbers. And somebody will have posted information on how to count stuff. And so I could look through there trying to figure out who can show me how to do the count I want to do or how to do the formula I want to do. And sometimes I might have to alter my search quote. Count numbers in a range, right? That's what we were just doing. So somebody out there probably did a video tutorial on it that we could go watch and see. So I'm going to do this one more time in a slightly different way. What I'm going to use is this idea with the and. So instead of doing it in 2 different commands and subtracting, I'm going to try to give my spreadsheet this command right here. So just watch me try it, and then you could try it after if you want. And then we'll try to answer some of the questions in the lab. So back to my spreadsheet. So in one shot, I'm going to try and make that calculation. So I'm just going to squeeze it in under this % here. So I'm going to do my count if again. And I'm going to tell it, look at the data starting in A1, colon, going all the way up to A520. And here's where my condition gets interesting. I need a condition that has two inequalities in it. And the connection between those two inequalities is and. How do I change color? There it is. So somehow I have to incorporate and in there. So I'm going to start typing the word and see if Google can help me with that. So after my comma, I'm going to type AND, and it says, hey, Google can use and. All right, I'm going to hit tab and see if it'll help me use it. Google says, yeah, type whatever your condition is here, comma, type your next condition. All right, well, let's see if it'll work. So my first condition was supposed to be quotes. I want numbers that are less than or equal to 99.81. Close the quote, comma. Let me double check my next condition. So I want it to be below, oops, over here, this number right here. But I also want it to be above that number over there so that it gets me everything in the middle here. All right, so let's see if I can do that. So let's see, quotes. I want to be bigger than or equal to my lower number, 96.96. 96.96. And I have a slight error here, but I think it's going to be good enough. Close parentheses on the and it's highlighting for me that I'm closing on the and then I have to close parentheses for the count, and then it's highlighting. I just closed on the count. So I'm going to hit enter and hope for the best. Ooh, nothing. Okay, so I didn't do the calculation right. So something's wrong with what I typed. Let's see if I can troubleshoot it. All right, count if this is true and that is true. Less than 99-ish and greater than 96. Interesting. I thought that would just work. And I swear I've done this before, but I mistyped something. Okay, so let's try one more idea. Equals count. There are other count options here. Count if S says count values depending on multiple criteria. And technically, to get numbers in between a certain spot, I do have two different criteria. Let's give that one a shot. So count if S. And it says first give the data and then give the criteria. Ooh, and it has different possible ranges. And sometimes it's really hard to figure out what they're talking about when they do this. I'm not sure if this one's going to work. I'm going to give it a try, and then if it doesn't work, I'll figure it out later and report back to y'all. And that's the thing about spreadsheets. We get into situations, we have a complicated thing to do, and we try a few times till we get it right. So count if first condition, if my data is greater than or equal to 99, and I can't see the number, where'd it go? 99.81. Something went wrong. Maybe. I lost my stuff. Darn it. Equals, start over, count if S.
I don't think it works.
You tried it, didn't work?
I think it says 0 if I did it right. Yeah.
Okay, so A520. And so this is one of those times where I go to the Google search and I start looking around for somebody that figured it out and they can explain it. And I know a lot about spreadsheets, but I don't know everything. I look stuff up weekly. And so it's just something we got to do. All right. So, and then my criteria, I want to see if any of those are less than or equal to 99.81. Close it, comma. And I think it wants another set of criteria or another set of cells. Which one? It wants more criteria, no, more cells and more criteria. Okay, so I'm going to try to repeat the same set of cells, A1 through, I don't think it's A520, comma, and then my other criteria, are there any cells bigger or equal to 96.96? And I have no idea if this is going to work. We'll see. We're taking a risk. Hey, okay, that worked. I got 496. All right. So to make that happen, what I had to do was give it the data in the first condition and then repeat the data and give it the second condition. And what it does is it connects those two with the and, which is what I wanted here. Right. And so sometimes it's possible to make a calculation using one command in one cell. Sometimes, like earlier, sometimes you just have to break it down into multiple cells like we did over here. So here I had to find this number, then find that number, then subtract them, and then do the percentage. And that's okay. For some reason, I've discovered as I've gotten older and used a spreadsheet more, I always like the challenge. Can I make this happen in one cell instead of 4 cells? It's kind of cool if I can, but it doesn't always work out. All right, so that was kind of sort of cool. So let's see, let's go back, take a break from this for a sec. Look at Lab 2's description. Where did I put Lab 2's description? It's here somewhere. There it is. All right. So a couple things we're going to do here. We're going to play with histograms and box plots. We made one histogram, although we didn't use a frequency table. That's okay. You guys looked at box plots already, I'm assuming? Okay. Well, we can take a look at that. Univariate statistics. That means we're calculating based on one set of data. Okay, uni means one. And so we did that. So our univariate statistics are, zoom out a little, that's where we calculated the count, the min, Q1, the median, Q3, the max, X bar, and S. All of these are statistics based on one set of data. So that's all part 2 means. So we got that covered. All right. And then we are going to examine some graphs and interpret some values. And so that's kind of what we're playing around with now. I did a crazy sketch of my graph here, and then I was playing around with different numbers on it. So we'll clean that up in a second. All right, so let's see. Things we wanted to do. We wanted to create at least 2 histograms with at least 5 intervals. Well, we made 1 so far. Notice it doesn't specifically ask for the frequency table. If I was in Excel, I would have to make a frequency table to make a histogram. Google Sheets gives me the options of making a histogram without a frequency table. That's okay. We're going to draw these by redraw the graphs we made by hand. So that graph, let's see, I must have done that on a different page. We'll redo that in a minute. We calculated the mean and the standard deviation. And then here I said, so based on the standard deviation, we want to make a mark. What number is 1 standard deviation to the right of the mean? What number is 2 standard deviations? What number is 3 standard deviations? So we're going to try and draw this graph next and mark those numbers on the axis. And then we'll answer some other questions. Is the data discrete or continuous? That was back in chapter 1. Any thoughts on discrete or continuous for this data set? Need a reminder what discrete and continuous mean? What do you think? Continuous? Okay. So discrete means it's countable, like I have 1 person, 2 persons, 3 persons. Continuous means you can break it down with like decimal places and fractions. And technically, if I had a really good thermometer, I could measure somebody's temperature down to the nearest 1,000th of a degree Fahrenheit. So yeah, I would say this data could be called continuous. Yeah, good. All right. Back here, so we answered that question. After we draw the histograms, we want to describe their shape. What kinds of terms can we use in describing shape? Well, we can say the histogram is symmetric, or the histogram is skewed left, or the histogram is skewed right. And then we could throw in some other phrases that we see in the picture. So we'll do that later. Did you all talk about outliers, how to calculate those with a box plot? With the interquartile range? Okay, so we'll take a look at that next too. We already started to analyze the data. We calculated the min, Q1, median, Q3, max. We didn't do the IQR yet. We'll do that in a moment. And then we want to play around with the box plot. All right, so let's start drawing a picture. So to do that, we need to go back to our data. There's the one where I made a picture, not that one. Maybe I got rid of it. I will just start over. All right, so I'm just going to restart here. I'm going to use Google's histogram feature instead of making a frequency table. So to use Google's histogram feature, we first highlight the raw data. We don't worry about classes or bins. What does Pete call them? Classes, bins, groups, buckets. When he makes a frequency table. I usually call them bins. Sometimes Google calls them bins. Sometimes they'll call it buckets. Sometimes you'll call them groups. But I'll show another example of that in a minute. So highlight all the data. Come on, data. Oh, almost there. Whoa, there we go. Okay. So to make again, in Sheets, a histogram without a frequency table, you highlight your raw data, and then you go to Insert a chart. Google usually guesses you want a histogram. And so it says, hey, here's a histogram you could have. You can tweak the histogram by going to customization. And in customization, I can give it a better title. So we did this earlier, let's repeat it again. So these are human body temperatures. There's only one data set here, so I don't need a color-coded legend. So instead of legend right, I'm going to choose legend none. Other things I can do here is change the bucket size. So I think earlier, what did we try? 0.4 maybe? So I type in a number, I hit enter, and say, that one's not bad. And I could try a different one. I could try 0.5, 0.6. That one's not too bad either. So eventually we decide on one we want. How many does this have? 1, 2, 3, 4, 5, 6, 7 bins. Usually we don't want less than 5 bins, and usually we don't want more than 20 bins. So we've picked some range in between. We're going to make 2 different ones. So let's say I like this one here. I'm going to go with this one. I should label the axis on the bottom. So horizontal axis title, I'm going to call it degrees Fahrenheit. And then I'm also going to label the vertical axis for my mother. So I'm going to switch from axis horizontal to axis vertical. And I'm going to call it count this time. You call it number of people. Anything you want that you think your audience will appreciate to help them understand the graphic you're showing them. And there's lots of other options, but that's good enough for now. So I'm going to insert that. Okay. And it's going to throw it up at the top because that's where I started highlighting. Oh, there's my other one right there. Okay. So now I have 2 different histograms now. So I can click on it and I can move it. Zoom out a little more. Just put it next to this one. And these 2 are similar but different, right? And I think because I have to hand draw it, I'm going to go with hand drawing this one because it's going to be easier to draw. So what I'm going to try and do is on a piece of paper, I'm going to try and reproduce this picture to the best of my artistic ability. What I'd like you to do is when you do that, I'd like you to leave some room underneath so that we can draw the box plot also. So we're going to draw the box plot along with this. So get out a piece of paper. I have a digital piece of paper here, so I'm going to drag this to an adjacent screen so I can see it and draw. So I'm going to attempt to draw on this screen here, and I'm going to be right back to see if I can get a magic pen. Still not see it. Magic Pen works. Yes, it does. Okay, good. So I can try getting you two. So again, we're trying to reproduce this graph, your graph. So I need axes. Excellent. And scale. So this is going by 0.6, right? Okay. 1, 2, 3, 6, 7. All right, and then let's see the sizes. Two hundred, so 50, 100, 150, 200. All right, 9 items in this one. So that's about here-ish. Next one has 30 items in it. Talking about here. $43. And about here. $178. It's kind of in the middle here. Pretty close to 150. Graph paper would be really nice right now, wouldn't it? I'll get that next time. What's that? You have some? Oh, good. Trisha, do you have graph paper? Line
You want
paper,
some?
though?
I have some.
33. Finally, 25. So right in the middle of this group. And then we're going to try and draw a box plot directly under using the same scale. That's crazy. Just broke the starboard. There we go. Okay. That's not useful. So once you draw the histogram, underneath it, you want to label the numbers for the box plot. So I'm going to start doing that on mine here. So let's see, my minimum was 96.5. So I'm trying to use the same exact scale as above here. Maybe I'll make this a little closer. 96.5 is right about here. And the 98 going to be, let's see, 97.8, 98.4. That's going to be right about here. 98.35, just to the edge of that. 98.8 is going to be right around here. And 100 is just inside. So this is what the box plot should look like. And I should label it. And have you guys in class compared box plots and histograms together like this on the same axes? No, so I'll talk a little bit what that means in just a moment. Other things we're going to need to calculate is the IQR and then potential outliers. Get to finish up in a few minutes. I got to get to another class. Almost done. And sometimes the scale we choose for our histograms can make it challenging to try and identify exactly where those numbers are. Oh, I forgot there was another thing we need to mark on our graph before we finish the box plots. We need to take the numbers for 1 standard deviation to the right and left, 2 standard deviations to the right and left, and we want to mark them on the axis of our histogram. That was one of the instructions there. So let's do that. So I'm going to use a different color for that. I'm going to switch to red so they'll stand out. So let's see, 1 standard deviation above was 99.1. So if that's 99 and that's 96, right about here, I think, would be one standard deviation above. One standard deviation below was about 97.7 roughly. So that would be about right here. So that would be minus 1s right there. And the mean was about 98.4. So right in the middle here is where x bar lives. And so x bar should be exactly in between one standard deviation to the right and one standard deviation to the left. So basically when we write things like x bar on here and 1s and negative 1s, we're kind of rescaling the axis using the standard deviation as our scale. So let's see, 2 standard deviations to the right was about 99.8. So if that's 99.6 and we scaled by 0.6, then I would say about right here should be 2s, 2 standard deviations to the right. So that the distance from x bar to 1s is the same as 1s to 2s. They look about the same. And let's go the other way. 2 standard deviations to the left of the mean was 96.96. Well, that's pretty darn close to 97. So 97 is probably about right here, I believe. So that would be minus 2s. Remember that our standard deviation was about 0.7. So then we didn't calculate 3 standard deviations to the right or left on our spreadsheet, but we can guess at it here. So let's see. If 2 standard deviations to the right was 99.8, what happens if I add 0.7 to that? So 99.8 plus 0.7, what do you think? 100.5, that sound about right? 0.7 to the right of 99.8. So I think that would
99.6. Or what did you say? Hold on.
99.8 plus 0.7. I think that's up to 100.5, which would be about right here. So that should be about where 3 standard deviations to the right are. Okay, subtraction in my head is always a bit harder. I estimated that 2 standard deviations to the right was about 97. What happens if I subtract 0.7 from that? 96.3?
Yep.
Which should be right in the middle here. So that would be minus 3 standard deviations. So 3 standard deviations to the left. So just a couple things I want to point out about all the marks that we made. We calculated that between the first standard deviation below and the first standard deviation above was about 70% of our data. Those are the 2 biggest stacks too, right? If we reach out a little farther, we get to add a few more people on either side. And we calculated that within 2 standard deviations on each side, which would basically be these 4 stacks in the middle, that was about 95% of our population. We didn't calculate how many people are within 3 standard deviations, but we can guess at that. So check this out. Here's my minimum on my box plot. Here's 3 standard deviations to the right. So our minimum is above 3 standard deviations to the left. It's inside of that. Also, check out our max. Our max is inside 3 standard deviations to the right. So how much of our data lives inside? All of it is within 3 standard deviations, so 100%. The empirical rule said that you should expect to find about 99% of the data. 99 and 100, they're pretty close. There's different versions of the empirical rule. You'll see some of them that say 99.2 or 99.3 or 99.5. It's kind of a ballpark estimate. And there's a little bit of difference here and there. All right, so some other things we got to do to finish this off. And I'm not going to be able to finish everything with you. I'll have to take some of it home. We needed to calculate the interquartile range. So I need to squeeze that in here. So let's blow this up. And I can squeeze that in between the max and X bar. So IQR. So remember, IQR visually on my graph here is the width of my box. All right, so we're trying to find the width of the box. So let's do that. So equals Q3 minus Q1. Enter. So this tells me the width of my box is about 0.8 of a degree Fahrenheit. The way you check for outliers is you find out, well, what's 150% of the IQR? So next thing we need to do is find out what is 1.5 times the IQR. So we want to widen that box a little bit. So I just go equals in an available cell. What is 1.5 times, and then click on your IQR. So that gives me 1.2. And does anybody remember what we do with that new number to figure out if there's any outliers? Don't remember. What we do with that number, so again, what we did is we found out our box is 0.8 wide. We expanded a little bit. We found it's 1.2 is the expansion. So then what we do is from Q3 here, we add the 1.2 to reach out to the right. And from Q1, we subtract the 1.2 to reach out to the left. Those numbers mark the places where most of our data should live. Anything outside of that, we say, is an outlier. So let's calculate those two values. So back to the spreadsheet. And this is getting a little bit messy here. I guess I'm going to squeeze it out to the left here. So usually I call those my lower and upper boundaries. So I'm going to type lower, and underneath that I'll type upper. So the lower number is equal to Q1. So we take the left side of the box, and then we take away our extended IQR, that 1.2. So this says if there are any temperatures below 96.8, that's unusually low for somebody's body temperature. It's not normal. According to this data, right? Every data set's different. Do the upper. With the upper, we start with Q3, the right side of the box, and we add on our extended IQR here. So that says 100. So this says if your temperature is over 100, that's unusually high for a human. According to this data, something's not right, maybe. Okay. And so then we look at our data set. Are there any numbers below 96.8? Well, yeah, we have a minimum of 96.5. So that person's body temperature is a little low. Like something's not quite right about them. I don't know. Maybe they were standing out in the cold for a while. We had another person that had a max of exactly 100, which happens to be the upper bound. So they're right on the edge of normal, according to this data. This data, right? There's other data sets of temperature out there. So it just kind of depends. So let's mark those numbers on our histogram. Usually what I do is I put little asterisks or stars on not my histogram, my box plot. So we need to find 96.8 and 100. So go back to the picture. I'm going to use a new color for that. I got red. So 100 is my max. So I'm just going to put a star right on 100. And then what was the other one? 96.8. So this is 96.6. 0.8 is probably about right here. So right about there. So those mark outliers. So what this lower mark tells me is that anything underneath that, from here under, is an outlier. So my data has some temperatures that are unusually low. So in this case, I have data that is unusually low. But I have no data that's unusually high because my max and my extended interquartile range number are the same. So there doesn't seem to be nothing is unusually high here. No outliers here. Nothing unusually high. Usually high. And every data set is different. Sometimes you'll find data that has some numbers that are a little high and a little too low. Some data set has neither. Some data sets have numbers that are unusually high but not unusually low. It just kind of depends. You never know what you find until you start making the calculations and looking at the data. Some other things to point out about this. Notice how wide the first quarter is. So just note on terminology. A quartile is an actual position on a number line. A quarter is a space between the minimum or some quartile marks. So the distance from this first mark to the second mark, that marks the whole first quarter here. Notice how wide the first quarter is, but how narrow the second quarter is. Look above at the chart. Notice above my narrow second quarter, I have a very tall stack. But above my wide first quarter, I have a lot of short stacks. Bottom line is 25% of my data has to live in the first quarter. 25% has to live in the second quarter. 25% has to live in the third, and 25% has to live in the fourth quarter. It just means my first quarter, the numbers are more spread out. There's a lot more variation. In my second quarter, the numbers are all very close together. There's not much variation there. People are pretty close to the same temperature in here. Pretty close to the same temperature in the second quarter, but there's a lot of variation in the fourth quarter. Okay? And so what you'll find is when you compare a histogram to a box and whisker chart, if you have a narrow quarter, you will find there will be tall stacks in the histogram. If you have a very wide quarter, you will find there will be short stacks in the histogram. No matter how you made your histogram, that'll be true. Okay. All right, I think we've kind of answered everything. You guys just need to kind of write your answers down. This is recorded. I'll post the recording so you can get to them. So where will I post that stuff? So keep in mind, earlier I sent you an email today, and that email had a link that got you into this version of MyOpenMath. Notice, so if I minimize the announcements for a minute, notice that this version of MyOpenMath only has 2 sections. The one you log in for Pete has a ton of sections, right? Experience 1, experience 2, and so on. What you're viewing here is the public version of my site. So I've made some of my site available to anybody on the internet, right? So my mom's not in this class, but she can go look at this page. You guys aren't in my section of 243. I didn't feel like making a whole new site just for the stats lab, so I put it here. So you should bookmark the link that got you to this page, because this is where I'm going to post stuff for you. So for example, after last week's lab, I made a video. I recorded some of that lab and I posted it here. So later today, I'll post this video that I just recorded with you. This morning before I came here, just in case the technology broke down, I did a recording of everything we just did, and I'll post that video too for fun. It's short, because I wasn't talking to people, I was just talking to myself. So what I'll do is for every lab, I'll post links for you to get to any materials that you need. I'll post a link for you to join me live. And then after the lab, I'll post any recordings that I have that are related in case you need to review back on something or if you missed that thing. Generally, we'll work on stuff in class, and sometimes you'll finish it in class and give it to me. Sometimes you'll give me a piece of paper. Sometimes you'll send me a spreadsheet, right? Like most of our work is in, I lost my spreadsheet over here, is in this spreadsheet, right? So you would just, there's 2 ways you can get me the spreadsheet. If you use Excel, you would email it as an attachment. In Sheets, you just click share, and then you just type my address, which you got when I emailed you. It's math.coach.parker. And then that's different than an attachment. It sends me to go view this file online. You can send it as edit, or you can send it as view. Either one is fine. If you send it as edit, if there's something wrong with it, I can make notes in there and say, oh, you could fix this. If you send me it as view only, then I would have to email you if there's anything wrong. And either way is fine. But math.coach.parker@gmail is where you can email me. I do have another college address I use too, but I like the Gmail one because then we can share files with each other super easy. And so that's kind of nice.
So you want us to send what we just
Yeah, so for this one, there's two parts for this one. There's the sheet where we do all our calculations. So I'd like you to share that with me. And then we drew our picture by hand, and then there's some questions to answer on that sheet that we talked about them, but we didn't write them down yet. So you can write those down. And if sometimes we finish it while we're together, and you just give it to me. If not, you just give it to me next week. Or you can ask the front desk to scan it and send it to me. All right, so let's just tell you a couple things up because I got to run to get to another class. Looking back at the lab description, which is here somewhere, lab 2 description. So we answered most of these questions in the spreadsheet. So if the number that the question asked about is in the spreadsheet, you don't need to write anything down. But if it requires you to like state a sentence, like is this discrete or continuous, then you got to write that down somewhere. So you could put that along with your pretty picture. So like number 5, you'll need to write down. Number 6, I just want a couple sentences. Tell me, describe your histogram to me. What does it look like? I know I can see it, but I like your description. Here on 7, I was asking you to guess if there were any outliers. And if there were, how could you find them? And then later on down here, we actually calculate the outliers. And then I ask about what does the IQR mean in this problem. So just your thoughts on that. And then here, remember we did deviation earlier. We talked about what that meant. Here I asked you to count. We did 1 standard deviation and 2 standard deviations. Where would 1.5 standard deviations put us on the number line? So I want you to try and calculate that. And if you get stuck, send me an email saying, I'm not sure how to answer this question. But give it your best shot, and then we can tidy any of this up. So what you guys need to do with me here is I sent you some emails before about lab 1. And if you haven't dove in and tried to do lab 1, you definitely want to do that soon. And so I have the printable version of the lab 1, which is just like this one. And I have a video of me doing the calculations. So take a look at that if you haven't already, and then try to get that finished up for next week. Next week I'll be in Pendleton, and so we'll do a live stream here. And do you guys do Gmail? You have Google accounts, right? So what I'll need you to do is write to Math Coach Parker from your Google account. So I have your Gmail address. And then what I'll do is I'll write back with how to connect to me with Google Hangouts. And then you can do that from any computer. And so what we could do is for next week, let's see, there's another student with the same last name as you.
Yeah, it's my brother.
Your brother, okay. So drag your brother along with you next time. And then Marianne is the other student in your class that's in lab. So if the 4 of you could meet together and do it, that would be great. So maybe next week, one of you guys could log in at the computer here because it has a microphone. So that means you can talk to me. These guys don't have mics, but the desk might have one. But Google Hangouts does a video chat. So I'll send you a link and you guys could try and log into the video chat. And we could get maybe Lori to help if anything technical goes wrong. And what I usually do, if there are technical difficulties, I'll have a pre-recording so we can just say, like the Pendleton people have trouble, scrap it, go look at the pre-recording and we'll talk. All right. Okay, so that's it for today. Thank you for playing. So you guys tidy that up and then email me if you have any questions. And then I've been copying Pete Hernberg, your teacher, with all this stuff too, so you can also ask him questions about it if you get stuck on anything. And so the point of the lab is we're going to just get more practice with the stuff you're learning in class. And now you guys are actually at least a day ahead of your classmates because we did standard deviation today. So that's kind of good. So you'll get more on that with Pete on Tuesday. Patricia, I finally get your name right. Mariana.
So for lab 1,